Hi there, my name is Brian Reily. I'm a graduate student at Arizona State University, and today I'm going to be telling you a little bit about some work that I've been doing towards my thesis project, which is a revision of the blue-green citrus weevils, genus Pachnaeus. So, in this presentation, I'm going to try to answer the following questions. First, what is Pachnaeus and why should you care about it? Second, what makes Pachnaeus different from similar genera? Third, how do you separate different species of Pachnaeus? And fourth, what issues remain with Pachnaeus after the work that I have done here? So first, what is Pachnaeus and why should you care about it? So here are a couple of stereotypical species of the genus. Typically, this name is referred to blue-green entomines with postocular vibrissae, which are often thought of as pests of citrus, hence the common name blue-green citrus weevils. Pachnaeus is native to the eastern United States, the Bahamas, and the Greater Antilles, and occasionally they've been introduced or intercepted outside of this range, usually in association with citrus, and there have been some significant outbreaks in past, usually in association with citrus. That said, there's actually a good deal of morphological variation in this genus. And I reviewed over 200 papers and recorded the plants that Pachnaeus was associated with from the literature. A summary of the results of that are shown here. Note that the number of columns corresponds to the number of plant families each species is associated with, and that the height of the column corresponds to the number of genera in that plant family. And as you can see, there's quite a bit of variation in their diets. So some important takeaways from this. Many species have no known plant associations. They're generalist feeders, most of them seem to be at least, and citrus, an old world taxon, represents the only member of Rutaceae represented, suggesting that there is no reason to think that they have a native host in this family. I'm in the process of getting this data into GloBeat now, the Global Biotic Interactions database. In terms of higher level placement, Pachnaeus is a member of the entomine tribe Eustolini, which is presently composed of about 25 genera, but realistically it's more because Exophthalmus is a wastebasket taxon. And Pachnaeus was moved to Eustolini by Franz 2012 from Tanimacini. The postocular vibrissae character that's supposedly the Tanimacine character turns out to just kind of pop up all over the place in entomines. And recently, Pachnaeus has been treated with an clade referred to as the Exophthalmus genus complex. But there's still a bunch to be done, and in the words of Woodruff, citrus-associated entomines are a Pandora's box of taxonomic confusion. In 2017, Zhang et al. Put out a molecular phylogeny of this genus complex based on these 6 genes. And the important takeaway from this is that both Pachnaeus and Diaprepes comprise monophyletic groups, and that they are closely related, but not sister taxa. So, I discovered Pachnaeus was, under strict priority, a junior synonym of Docorhinus. No one ever used Docorhinus, until someone did, which created some nomenclatural instability. I've tried to fix this formally by petitioning the ICCN, and all of this is to say, please comment on this case if you feel so inclined. So, next, what makes Pachnaeus different from similar things? Historically, Pachnaeus has been separated by the presence of postocular vibrissae. All species in the genus have this character, albeit sometimes it's hard to see, and this is useful in eliminating similar taxa, except Diaprepes, for which we often need more characters. One reasonably good character is the shape of the ocular suture. In Pachnaeus, it's shorter, more lateral, and apically directed forward. In Diaprepes, it's longer, more ventral, and apically curved upward. But probably the best character I've found for distinguishing Pachnaeus from anything else is the structure of the endophallic sclerites. In Pachnaeus, there is a single tubular sclerite, and here I confirm that this is a synapomorphy for this genus. So, third, how do you separate the different species of Pachnaeus? To save some time in going through the lower level taxonomic history of this genus, I'm going to start with O'Brien and Widmer's 1982 catalog, which was the first modern work to treat all extant species in the genus. They listed 7 species and 1 subspecies. In 1988, De Zayas added 2 species from Cuba. In 1992, Lopez Castilla added 2 more species from Cuba. And in 2008, Turnbow and Thomas indicated that there was one yet undescribed species from the Bahamas. So, when I started this project, there were 13 taxa to deal with. After looking at over 1,500 specimens from 20 collections, and all the original descriptions and subsequent redescriptions, and types or images of types for most species, and specimens from the type locality when those were not available, there are now 23 species of Pachnaeus, and here they all are nested within some of the clades I've managed to work out at this point. So let's work through some of these clades. The first one is a large group that I'm calling the Citri species group. And members of this species group have an impressed pronotum and are from Jamaica and the Cayman Islands. There are several subgroups nested within this group. The first is the Marmoratus subgroup, which have raised pronotal ridges. The second is the Gordoni subgroup, which have a band of white scales on the metafemur and a denuded dorsal patch. The third is the Andersoni subgroup, which have reduced scales and are from the Cayman Islands. And the fourth is the Eisenbergi subgroup, which have bluish scales and white pronotal patches. The next major group is the Opalus group, and these are species with short quadrate rostra and weakly defined central carinae. They're mostly from the continental US and Bahamas, and this group is comprised of two subgroups. The first is the O'Brienorum subgroup, which have a smooth pronotum and a patch of dense scales in the interocular region. These are from the south central Bahamas. And the second subgroup is the Howdeni subgroup. These have a rough punctate pronotum and are from the continental US and northern Bahamas. Next is the Psittacus group, and these have densely overlapping scales and a slight constriction at the pronotal bases. Within this group is the Costatus subgroup, and they have a quadrate central rostral carina. There's the Pater group, and these have raised rostral carinae with deep depressions between them. There's the Litus group. These have dentiform humeral projections. The central Cuban specimens of this group are problematic. They're either cryptic species or a lot of variation in Litus, and as a note, Litus is regularly moved around with citrus and not, despite what the literature suggests, native to the United States. We have the Havana population. And then there's a few one-off species. The first is Azarescens. These have tumescent rostra. These are Cuban, but introduced into Florida, which has not been reported previously. And lastly is Someri. This is a species that's been moved around a bit. It's not very typical of the genus because it has a long rostrum and patches of shaggy elongate scales that are more similar to those in Jamaican species of Exophthalmus sensulato. It makes me think that this may be a basal species in this genus. So there's your species. What issues still remain with this genus? Well, first, Citri has multiple morphs. There's a pink one that I think is probably just a preservation artifact. There's a typical blue morph. And then they get bigger and gray in the Blue Mountains. I think this is just plasticity, but I'm not sure. And as I mentioned, central Cuban Litus specimens are problematically variable. And there's limited data. Many specimens are just labeled Cuba. This may be multiple species, but I'm not sure. Lastly, Azarescens is really variable. But that variation doesn't seem to correspond to populations. So maybe it's just a really variable species? So to solve some of these issues, I'm working on Ediagal aversion with techniques modified from Van Dam 2014. Pancreatin clearing is working just great, but averting is not working so well. So I'm working with a few people to try and build myself a jig to hold all the things in place while I work. So with that said, I'd like to thank all the people and institutions who have helped me with this work in the past. I could not have done this work without you. And just to end on a fun note, here are all the namesakes of the species that I'm naming. If you have questions or comments, I can be reached at bhreily@asu.edu. And thank you for your time and attention.